Okay, so next problem is the two sphere is given which is rested in a trench of 30-degree inclination. The two rulers are identical and weighing a same weight of 200 Newton. So we need to calculate the support reaction or the reaction at the contact surface at A point, at a contact B, at a contact C, and at contact D. Okay, so now first thing what I'll do is I'll calculate the or reproduce the reaction. So there's a reaction will be here which is RA, always normal to the plane. So this is your RC. So this reaction will be I'll call as RB itself. Then this reaction will be RD. Okay, so this reaction making a perpendicular 90-degree to this, but this reaction is parallel to this. That means with respect to horizontal, RB makes a 30-degree inclination. And what will be the angle produced by RC and RA? So for that, what you can do is just I'll draw the trench over here. The reaction will be 90-degree to this. Okay, so if I just extend the line, okay, if this is 30-degree, we know that the angle between interior angle of a triangle will be 180. If this is 30, this is 90, then angle produced by the RC with respect to horizontal will be 60-degree. So that means RA as well as RC makes an angle of 60-degree with respect to horizontal. So now I'll draw the free body diagram of that. So first I'll just make the dotted line wherever I'll get the reaction as well as the self weight. For this also I'll make the same thing. There's a self weight and there's a reaction. So the reaction will be somewhere over here, which will not be 90 degree. So this is your RD force, correct? So this is RB. So this force will be reaction will be acting to this, and this reaction will be acting to this pair. Okay, RB. Then there's a RC. Okay, self weight, right? It will be acting the center. So 200 Newton. Okay, so this makes angle of 60-degree with respect to horizontal. Similarly over here, so there's a RA. Again, this makes a 60-degree inclination. So there's a self weight which is of 200 Newton given, and this makes a 30-degree inclination because the force RB is parallel to the 30-degree inclination. So whatever the inclination produced by this line will be equal to the inclination produced by the RB. So the angle for this is 30-degree. Okay, this is the joint diagram, free body diagram what we'll get. So in this case, we'll consider this pair first because it has two unknown reactions, whereas it here 1, 2, 3 unknown reactions are there. So we cannot find out the reaction with the use of that. So what I'll do is I'll consider this by considering the joint diagram. So here there's a the load of 200 kN acting downward, and there is a RA force which makes an inclination of 60-degree with respect to horizontal. Then we will not consider this RB in this joint diagram because this RB will act on this sphere and this RB will act on this sphere. So the reaction produced by this sphere to this, reaction produced by this sphere to this. So in this case, the RB will be this, which makes an inclination of 30-degree. Okay, so this is the joint diagram what we'll get. So now what I'll do is I'll use this joint diagram to calculate the unknown reaction. We know that if you are applying the Lamè's theorem, then the forces should be in such a form that it should be a converging pattern or diverging pattern. So what I'll do, I'll draw or rearrange the forces in such a way that all forces should be in a diverging form. So I'll take this RB on the first quadrant with the use of your principle of transmissibility. Then RA I'll take on this column, which is quadrant, and the weight is of 200. Okay, RB makes some 30-degree inclination with respect to horizontal. RA makes 60-degree inclination with respect to horizontal. This is the diagram what we'll get. Now what I'll do is I'll use the your Lamè's theorem to calculate the unknown forces. So this, for the calculation of by use of Lamè's theorem, we should calculate the angle between the all the forces. Okay, so if this is 60 degree, then 90 plus 60 will be 150 degree, 30 plus 90 will be 120 degree, and remaining will get a 90 degree. 30 means this is 60, 60 means this is 30, 30 plus 60 will be 90 degree. These are the angle what we'll get. Now we use the Lamè's theorem, which said that magnitude of each force is directly proportional to the sine of angle between other two forces, which is nothing but, if I consider 200 force, the angle between other two forces is 90 degree. So it will be sine of 90 degree, which is equal to, I'll take RB divided by sine of angle between other two forces, which is 150 degree. Similarly, RA will be equal to sine of angle between other two forces. So if I use this equation to calculate, then I'll get RB by sine 150 equal to 200 by sine 90. Okay, so then RB equal to, I'll take sine 150 on the other side, so 200 into sine 150 divided by sine 90. If I calculate, then I'll get RB value as a 100 Newton. Similarly, if I calculate RA value, then RA by sine 120 equal to 200 sine 90. So RA will be equal to 200 into sine 120 degree divided by sine 90 degree. So the RA value what I'll get is 173.204 Newton. These are the value we'll get with the use of joint 1 or the your sphere 1. Okay, now we'll calculate the other unknown forces by using this joint diagram. So rub this part. So now I'll draw the second joint diagram. So in this case, there's a RD reaction, there's a weight of 200 Newton, then there's a reaction RC which makes an inclination 60 degree with respect to horizontal, then there's a reaction RB produced by this sphere, so which makes an inclination of 30 degree. This is the joint diagram what we'll get. Okay, so now with the use of this we can calculate the other unknown forces. So here the number of forces are 4. So if the number of forces are more than 3, we cannot apply the Lamè's theorem. Then we use a equation of equilibrium, which is summation of fx equal to 0 and summation of fy equal to 0. With the use of that, unknown forces can be calculated. Already we have calculated the RB value, which is 100 Newton. So now I'll use the summation of fx and the summation of fy condition to calculate the unknown forces. So first is your RB, which is 100 Newton cos 30, which is moving left side, so minus, then minus RC cos of 60 degree, then plus RD equal to 0. So here there will be 2 unknown, so I can write I'll keep as it is RD equal to, so if I calculate the 100 cos 30, it will be 86.660. If I take it on the other side, it will be positive value 86.60 plus RC cos 60. So I'll keep this as a equation 1. Okay, now we'll move on to the second condition, which is summation of fy equal to 0. Whereas in the summation of fy equal to 0, RB is your 100, which is acting downwards, so minus 100 sine 30 degree, then plus RC cos 60 degree, then there's 200 force which is acting downwards, so minus 200 equal to 0. So 1, 2, 3 forces will get. So this is the summation of Fy. If I simplify this, all those things, so then I'll get 100 sine 30 will be equal to 50 minus 200, so it will be 250. So I'll get RC cos, sorry, this will be sine 60, wrong, because away from the angle is sine, so sine 60, sorry, there's a mistake. So it will be sine 60 minus 250 equal to 0. Then RC equal to 250 divided by sine 60. So we'll get RC value as a 288.67 Newton. Okay, substitute this RC value into this equation to will get the RD value. So RD will be 86.60 plus 288.67 cos of 60 degree. So RD value what we'll get is 230.94 Newton. Okay, these are the unknown reaction what we'll get. So RA as what we get is 173.204, RB as 100, RC as 288, then RD as 230.